Okay, let's continue. Okay. All right. Where are we? Okay. Last time, I remember doing the sine cos. I think that's where we finished. So let's do this next batch. Right, let's have a look. For the following exercises, find the local and absolute minima and maxima. Absolute, the global, okay. Okay. 129. Well, it's going to be a global min, it's a quadratic. The derivative is 2x plus 4 equals 0. So that's at x equals minus 2. Do we need the y values? Let's have a look. Do they want the y values? Yeah, they do. So that's y equals 4 minus 8 is minus 4 plus 5 is minus 1. Oh, Stephen. 1. Not adding correctly today. 4 minus 8 is minus 4 plus 5 is 1, Stephen. 130. Oh, interesting. Interesting. 3x squared minus 12 equals 0. So x squared equals 4. So x equals plus or minus 2. So that's going to be 2 and minus 2. Okay. 8 minus 24 is minus 16. And then minus 8 plus 24, which is 16. Interesting. Okay. So, but are these just local? Oh, they say find the local. Why did I miss that? What's wrong with me? Come on, Stephen, focus now. Find the local and absolute. Okay, so this one here is global min. This can only be local. And we can calculate the second derivative, which would be 6x. So the positive is the minimum one. Local min. That's kind of weird, isn't it? Oh, sorry, the x. I'm looking at the y. The x negative. So local max. And then 2 minus 16 is local min. Okay. 131. Ooh, now, no local max could be a global. Let's have a look here. The global min. The first derivative is 12x cubed plus 24x squared minus 36x, which is 12x times x squared plus 2x minus 3. It's 12x, x plus 3, x minus 1. So we can have 1 minus 3 or 0? Well, 0 is 0, that's fine. And 1 we can get is 3 plus 8 minus 18, which is minus 7. And then minus 3, let's see what that one is. Ooh, minus 135. Okay, now if we calculate the second derivative, that would be 36 x squared plus 48x minus 36. So if we put 0 in here, we don't know. Let's put minus 3 in. So that's positive, so that makes it a local min. And then if we put in 1, we get 48, so that's also a local min. There's no global max because as I go to infinity, this will go to infinity. But could there be a global min? We need to look at the third derivative, which is 72x plus 48. So at 0 is positive. So this is a rise and saddle. So could that local min be a global min? Ooh, how can we tell? How can we tell? Could we get any lower than this? Let's see what we can do here. Y equals 3x squared, x squared. Oh, I shouldn't take the 3 up. 3x squared plus 8x minus 18. Okay. It's a quadratic times a quadratic. So it makes me think that that is indeed a global and a local min. Global plus local min. Let's see if I'm right or if I'm wrong. Absolute min at minus 3. Excellent. Local max at 0. Local min at 1. So I'm wrong here about 0, 0. Oh, my mistake. When you put 0 in, you don't get 0. You get minus 36, which makes it a max. Stephen. Just not having good time today with my mental arithmetic. All right, let's be more careful. 132. Okay. Why? I don't think there's a global max or min because when x goes to infinity, we get infinity. And when it goes to minus infinity, we get minus infinity. So it can only be local max and mins. So let's see, the y derivative will equal 3x squared, 1 minus x power 6, plus x cubed, times 6, 1 minus x power 5, with a minus 1. So that needs to equal 0. So that needs to equal that. So one possibility is x equals 0. Or, now if we remove that possibility, so that would be 1 minus x power 6 equals 2 x 1 minus x power 5. So you could have x equals 1, or, so let's get rid of that possibility. 1 minus x equals 2x. So that means we have x equals a third. So we've got 0, 1, or a third. So 0 yields 0, and 1 yields 0. What will a third yield? Yeah. 64 over 19,683. Ugh. Okay. So, without getting into the second derivative, maybe we can just figure out cubic time an odd time 0. Maybe I do need the second derivative here. Do I have to get the second derivative? I feel like there should be a smarter way. So when x is slightly bit above 1 or below 1, so it to be a max. So I think this one would be a local max. But I'm not sure about this one. When x is near 0, this is nearly 1, so I think this would be a saddle. Then a third. Maybe this one's a local min. I'm trying to picture the shape of it. Let's see if my intuition was correct. Okay, 0, 0 is a saddle. That was correct. Max at a third, min at 1. Max at a third, min at 1. Ah, I had it backwards. Not too bad, I suppose. Min. Yeah. No absolute max or min, though. Okay, let's continue then. Okay. 133. X plus 3 times x minus 2 over x minus 1. X is not 1. So I guess there's no advantage in factorizing. Oh no, it's not -2. Oh, maybe it doesn't have factors. No factors. Yeah, okay, but it can't be 1 anyways. The derivative is the bottom squared. The bottom times the derivative of the top minus the top times the derivative of the bottom should equal 0. So 2x squared minus 2x plus 1 is minus x minus 1 minus x squared minus x minus 6 equals 0. X squared minus 2x minus 7 equals 0. I must have made a mistake because that's a messy answer. The bottom squared, the bottom times the derivative of the top minus the top times the derivative of the bottom. X by 2x is 2x squared. That's x minus 2x is minus x minus 1. Okay, x squared minus x squared is x squared. Minus x minus x minus 2x. Oh, maybe not. So that's 1 plus 2 root 2. 1 minus 2 root 2. Okay, and then the y value then. Okay. That would be 3 plus 4 root 2. And then 3 minus 4 root 2. Okay, now as x goes to infinity, this will go to infinity. And when x goes to minus infinity, this will still go to infinity. So there's no global max. This is a quadratic. I think we could have a global min. Second derivative though. So first derivative is x squared minus 2x minus 7 over x minus 1 squared. Okay. The bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared, and we don't care about the bottom squared because we only care about the sign. So let's see now. Okay. Right, let's put in the first point. 1 plus 2 root 2. And you'll get a positive. So that will make it at least a local min. And then if we sub in 1 minus 2 root 2, we'll get a negative. This makes it a local max. We said that there is no global max, but could this be a global min? Now, could it be a global min? No, I don't. When x approaches 1 from the left or the right, we can get a positive or a negative, but the top is always positive. So you can, yeah, so I think there's no global min either. So you only have local min and local max. Let's find out. Local and local. Nice. Nice. Okay, and lastly, 134. Y equals x minus 1 times x plus 1 over x minus 1. And if we do not allow it, x is 1, then this function can be simplified just to x plus 1. Which has no global max, no global min, no local max or no local min. There's nothing. So the graph is going to look like this. Yeah. Then there's a break here at 1, and then just continues like that. Let's check it. Yeah. Yeah. Weird one. Yeah. Weird. Okay. That's a good place to wrap it up there for today, I think. What's happening next time? Tech questions. For the following functions, use a calculator to graph the function, estimate the absolute local, and yeah, so estimate from the graphs, and then some story questions after that. Looks decent. All right, super. Thanks for watching.